All right, while we're dipping our feet into the ladder diagram programming in Siemens, I want to show you how they break it down, because if you're coming from something like Allen Bradley, like I am, or some other environment, you've probably seen you've got something like program files or, blocks of, code, and then you've got just rungs on a ladder, rung 1, rung 2, rung 3, all the way down. Siemens has decided that there's a better way to do it, and whether you think it's better or not, they've decided that it is, and that's what they've done. So they've broken things into networks, and then within a network, your different rungs don't have any numbers. So when you're trying to talk to somebody about a program and say, I want you to look in this block in this network, and it's like the seventh one or the 10th rung down. So you kind of have to go, oh yeah, okay, I think I see what you're talking about. It's really kind of tricky. It's harder to discuss the program using this system, but that's okay. We love Siemens anyway. So all right, let me show you what this thing looks like. When we get into ladders here, first thing we have is blocks. Now I'm going to show you, I'm just going to add a new block here, and I'm going to call it ladder 2. That's going to be a function block, and oops, I want to make that ladder. Okay, and hit OK. Now don't worry about that whole interface right there, because we'll get into what that is later on. But for now, you can see I've got my main program, which has got ladders, and then I've got my ladder 2 function block, which I just created, and guess what? It's got more ladders in it. So how does this thing structure? Well, all right, I come down here, and let's say I start using this, and as soon as I start using this network, it creates another network down here for me. So I'm going to drop some controls in here, and then I say, well, I actually need like 2 or 3 rungs here to do this function. So maybe I'm setting up something like, standard digital control logic using a trigger, a hold-in, and an interrupt. If you don't know what that is, it's coming. Don't worry about it. For those who already know what it is, you know that usually consists of at least 3 rungs of code. Or for programming an alarm, that usually consists of about 3 rungs of code for a single alarm. So in this network, I can come up here and, I can have all kinds of things selected. But let me select the bar way back here. And you see this open branch? I'm just going to click that a couple of times. So now I've got these 2 little stubby looking arrow things here. And believe it or not, those are also rungs, or I can turn them into branches. So let's say I want to turn this into a branch of this. I've got one condition here, which is going to determine when to energize this. But let's say I'm going to set this up as digital control logic. So this is going to be my trigger, this is going to be my output, and I need a hold-in and an interrupt down here. Well, let's just go ahead and put this stuff together. So here's my trigger, here's my output, and I'm going to come up here and I'm going to take my normally open contact, bring it down, and I'm going to drop it right here. And this is going to be my hold-in, so it's going to tie right back to output. That's how a hold-in works. And then I need an interrupt here, so I'm going to take my normally closed contact and pull that here, and I'll call that my interrupt. And I just take this and drag it right up here. So now that became a part of this rung, and now I've got a single rung, all of this right here, with one branch. coming down below the normal branch. So great. That's how I can do that. But what if I just want another rung? Well, no problem. I come down here and I can put in, let's say I want another, normally open contact, and then I want to put an output right there next to it. There we go. So just like that, within this network, I've got all of this stuff. So what if why do I have these multiple networks? Well, maybe all of this right here is controlling, let's say one device or one alarm or one system. Well, down here in network 2, I can have it controlling something else. So if I come up to network 1, I can say device 1 control. Great. And so now I know what network 1 is. And when I come down to network 2, it can be device 2 control. Great. So now I've got a little bit of documentation worked in here, and now it helps me kind of organize. I still have no way of, telling somebody what rung number this is. That's the part that I don't like. But at least I can go and say, it's in network 1 of ladder 2, of the LAD 2 block, okay? So I can at least point that much out. Now, while we're in here talking about structure, I also want to talk to you a little bit about program flow, okay? So you're kind of got an idea of how a ladder logic program is, structured in here, but how do you get around inside of that? Let me show you how that works. When we come back to main, okay, this is the program block that runs all the time. Whenever you turn on the processor, it says, where's my main block? Here it is. I'm just going to run it over and over and over again from top to bottom, left to right, down each rung. I'm going to go through network 1 first, then I'm going to go to network 2, then I'm going to hit network 3, and if there's 100 networks, I'm going to go left to right, rung to rung, down every single one of those networks, and when I get to the end, I'm going to jump back up to the top and start all over again. That's how this program works, okay? Now, what about these other blocks I'm creating? Like I've created this ladder 2 block. When does that run? Well, the answer is right now, it does not run. It never runs. It never gets called because I haven't told it when to happen. If it's not in the main program file here, it doesn't get called. So, okay, I want it to happen. Let's say I want it to happen after network 1 and 2 are done. So I come down to network 3. And watch this. I'm just going to drag my ladder 2 right down here and let it go. And do I want it to have a data block? Yes, I do, because that's where it's going to store its information, which is going to be persistent from scan to scan. That's important. 99% of the time, I want a data block. So yes, I'm just going to go ahead. Do I really care what it's called? No, not really. So just let it be called ladder 2 data block. I couldn't come up with a better name than that. I mean, I know where it is. I know what it's linked to. Hit OK, and great. Now I've got a place for it to store the data for all of these registers that I have created or will create inside of my ladder 2 block. Okay, so now you can see right here, I'm calling this ladder. Now, when I'm scanning my main block and it comes down here to network 3, it's going to say, I need to run ladder 2. So it's going to come into ladder 2 and, whoops, I clicked on the data, not the actual function block. Okay, it's going to come in here and it's going to run all these networks from top to bottom. Once it gets to the bottom, it's going to come back in here right where it left off, and it's going to jump into the next network or the rest of the rungs that I might put below it in network 3. So that's how it works. And then from ladder 2, let's pretend that I have another function block, and we'll call this ladder 3, but I could really call it anything in the world that I want. And whoops, that's going to be an LAD. Okay. And it pops up right here. And let's say that while I'm working in ladder 2, I come to a point where I want to call ladder 3. Hit OK on that. And, let's say ladder 3, whoops, I want to pull that normally open contact here. Let's say that that's conditional upon my output from above. So when this output is energized, then when I come down here, I want to scan ladder 3. Well, if this is de-energized, it's going to work its way down here, come here, say, nope, can't go through, and it's going to pop all the way back. And once it's done with that, it's going to go back to ladder 2, where I called ladder 3. And once I get done here, it's going to say, well, you know what, there's nothing else. So it's going to go right back to main where it was called, scan anything below it, and go back to the top. And, when I come in here and output does happen to be energized, it's going to scan ladder 3 and say, great. It's going to come in here, go through all this logic, come back to ladder 2, pick up where it left off, anything else below it. Once it finishes, it's going to go back to main. So that's how you add different blocks into your program and get them called. You basically just drag those guys and drop them right there into some existing part of your program that is being called, obviously. And there you go. It's going to execute those as well. Now, there's one last thing I want to show you, and this is not particular to ladder programming. This is something that is, just how TIA Portal is set up, but I want you to see it. So when I come over here and click Add New Block, you see I've got different kinds of blocks. I've got data blocks, I've got functions, I've got function blocks, and I've got organization blocks. Okay, when I click organization blocks, what are those? Here are the different types of organization blocks, and basically think of these as non-standard blocks, okay? Most of the time, you're going to be using function blocks. These blocks under organization block, these are exceptional, okay? When I say exceptional, that doesn't mean they're wonderful and great. It means rarely you will use these. So when I need a time delay interrupt, what is this? This block will interrupt cyclic program execution when a specific delay time has expired. Okay, so my program is running, cycling, but for some reason I want something to happen that interrupts the flow of my program on some random given time interval, like, every 20 hours or something. Okay, this is the type of block that I throw in and use. Most of the time, we don't want things arbitrarily interrupting the flow of our program. That's not to say that it stops everything. It just kind of injects itself in at a certain point. And, it might happen so fast that you don't even, it doesn't affect your program at all. When something scans, we're talking milliseconds here. So the fact that it's saying it's an interrupt, that doesn't mean it just slams on the brakes of your entire process. All that means is, instead of continuing that scan, it jumps over here, executes itself, and then it goes right back in and resumes scanning. Well, maybe you want that, maybe you don't. Personally, I would never really use these organization blocks. I'm not saying it's a bad practice. I'm not saying it's something, that you shouldn't do. But my personal style is I want my scans to happen, cyclically, repeatedly, all the time. If there's something that needs to be evaluated on a time basis, it's going to have a real-time clock that it evaluates, or it's going to have a timer that it evaluates. And when that happens, then it's going to direct over to another, block of code, and it's going to execute that. Then it's going to come back into the normal flow. I'm not going to have this block here that just all of a sudden, just blurts itself into the program and then steps back out again. To me, that's not elegant. What's elegant is, I evaluate the conditions every time. Do I need to run this right now? No? Okay, then I'll keep going. How about now? No? I'll keep going. Rather than have this independent operator just kind of, forcing itself in the middle of my program. So organization blocks, read through those, experiment with them. They're a really neat idea. They are useful. They can be used well. So go ahead, take a look at those. But for most of the time, we're going to use a function block. Now you see here we've got functions and then we've got function blocks. What's the difference? Functions don't use dedicated memory. Function blocks do. Well, using memory, not using memory, what does that really mean to us? Obviously, every bit of program that we have is using some kind of memory somewhere, right? What this is talking about is the actual data, the registers that we're using inside of these blocks. For a function, it is not going to have persistence from scan to scan, okay? Those are big words. What do they mean? Well, when I'm managing temporary memory inside of a function, let's say I set a few things and, I latch a few booleans or bits and things like that. By the time I come back around to the next scan and evaluate this function again, they're not set anymore. Everything just got wiped and reset, and it's like the previous scan didn't happen. Why would you want that? Well, sometimes there are sections of code that you might want to happen, in multiple different places in your program. And if I'm evaluating this function for my heat exchanger, I don't want the data from that to impact my water cooler. Does that make sense? I want to start with a clean slate every time I evaluate this function. And this function, I go into it, and maybe it makes some changes to permanent global memory, but its own internal data does not persist. It doesn't remain. That's what you might want to use a function for. Otherwise, you're going to use function blocks. A function block is something that stands on its own. It's not something that you're going to be calling this to do 10 different things all over the program. That's what a function's for. The function block, does its own thing, like, hey, I'm managing the alarms for this program. Hey, you only need one function block that does that for your whole program, and you definitely want the data to persist. When it sets alarms, those alarms need to stay set. When it triggers a bit that says that this alarm has been triggered, don't reset it. We want that to remain that way. So, most of the time when we're creating a new block of code, 90% of the time we're going to want to use function blocks because we want them to be persistent. Eventually, as your programming gets more advanced, you might want to set up little utility blocks of code that perform some function and don't need to persist, and you can call them from several different places in your program. That's what you've got functions for. Data blocks, you really don't need to create these because it's going to automatically create its own data block, so let it. If you need to create your own data block for organizational purposes or something, there's certainly no reason you can't, but that's it. So that's the different types of blocks in here, and again, 90% of the time, function blocks are probably all you're ever going to need. If you only ever create function blocks, you will be able to program everything anybody ever puts in front of you. So you can kind of think of the rest of those as luxuries or conveniences. They're there for you if you need them, but or if you want them, I should say, but you'll probably never really need them. And the other thing that I want to show you up here is under language, we've got 3 different options: LAD, FBD, and SCL. We've got 3 because of the processor we're using, and right now I've got the 1200 processor set up. Once we get into a little bit more heavy-duty programming, we're going to use a 1500 series processor instead, and that's going to give us more language options. So we're going to have different languages available to us, and we're going to be learning them all. So that's what I want to show you. Now you know how the programs are structured. More specifically, you know how ladder programs are structured. You know that things are going to be flowing from the left to right. If you haven't taken PLC 1, and if you don't already have some idea, the last thing that you need to really know, which hopefully this is a refresher for you at this point, is that on each of these rungs you have conditions on the left and you have actions on the right. Now, you don't always have to have conditions, but you do always have to have some action at the end of a rung. What's an action? Action means you're doing something. You're energizing a Boolean. You are moving a value from one place to another. You're performing an addition or subtraction and storing that value somewhere. That's the kind of actions that we're talking about. Conditions means we're evaluating memory, or we're evaluating input. We're evaluating something and deciding whether or not to perform those actions that are on the right of our rung. So we're looking and saying, is this energized? Yes or no? Does this value equal 50? Yes or no? Are these two things the same? Yes or no? Is this signal coming in from this input greater than this set point? Yes or no? And if we pass the conditions and the PLC says, yes, this is true, yes, this is true, you might have 1 condition or 10 conditions, then it says, okay, go ahead and take this action. The action's over on the right. If we don't have any conditions, every time the PLC scans, which might be 10, 20, 50 times a second, we're going to take that action every single time. So that is how ladder diagrams work. We go rung from rung. We go left to right. We evaluate the conditions. If all the conditions are true, we take the action. If all the conditions are not true, we skip down to the next branch if there is another branch. What about these conditions? Are they true? No. Then we go ahead down to the next rung. Are these conditions true? No. Is there a branch? No. Go down to the next rung. Are these conditions true? Yes. Go ahead and take this action. Is there another rung below here? No. Okay, let's go to the next network. Is there another network? No. Okay, let's go back up to the top and start back at our main ladder, and let's start evaluating again. So you know how this stuff flows, you know how it's structured, you know what it looks like, you know where everything goes, you know what type of function blocks are available to us, you know how to call those different function blocks to make sure that they're actually executed rather than just sitting here in your project and never being called anywhere. So that's what you've learned in this lecture. It's quite a bit. We're going to proceed from there, and we're going to actually start getting into the instructions and see what some of these different conditional operators are and some of these different actions are. And that's really the last piece that you need to be able to start creating logic. So I'm going to give you that. Later on in the course, I'm going to teach you some more advanced logical structures. Things that if you've already been through PLC 1 are going to be a refresher for you. If you haven't, that's okay. I'm not going to dwell on those things, so don't worry. I'm not going to just, bore you to tears. But you are going to see HOAs, you are going to see digital control logic, things like that. So that's it. Let's break from this lecture and we'll jump back in on the next.